Hello wonderful person, this is Anton, and today we're going to discuss some of the recent discoveries and some of the recent observations from the now famous third interstellar comet 3I Atlas, mostly focusing on the latest results from various studies in the last few months. And that's because there's actually been a kind of a flurry of new studies, because as I mentioned in some of the previous videos, the comet is leaving the solar system, and so it's going to be more and more difficult to study it, with the entire object becoming invisible in the next few months. And so here we actually have a series of new studies, including a major one that was just published a few days ago, that fundamentally change our understanding of what we knew about this object, where it potentially came from, and perhaps more importantly, what it tells us about our own place in the galaxy. And so let's discuss some of these updates and discoveries in a bit more detail, but I guess first, so where exactly is it right now? Specifically, late April of 2026. Well, it's now past the orbit of Jupiter and is heading back into the darkness of space. But even though it's moving so fast, it is going to take it a very long time to leave the solar system. But even before it left us with a kind of a fingerprint of the star system that existed billions of years before our own solar system. And that's because now we are almost certain that wherever this came from is billions of years older than the Sun. But I guess first is super quick recap, just in case you already forgot everything about this and have no idea what I'm talking about. And the story starts on July 1st, 2025. The automated system known as Atlas discovers this new object, an object moving just a little bit too fast to be coming from the solar system. And within just 24 hours, it's confirmed to be the third ever discovered interstellar object. This is of course after Oumuamua in 2017 and Comet Borisov in 2019. But unlike Oumuamua, which was a bit of a mystery and was producing strange emissions, 3I Atlas is clearly a comet. Or basically a kind of a dirty snowball, roughly a kilometer across, that started to vent gas and dust as it approached the Sun. But once again, because it was moving so fast, astronomers only had a very narrow window to study everything. So it's actually been less than a year, and it's already almost invisible, just because it's moving at something like 137,000 miles per hour, or 220,000 kilometers per hour. But because we saw it coming earlier than the previous visitors, this allowed astronomers to point every major telescope at it. So everything from the James Webb to the ALMA radio telescope in Chile. And while one of the biggest discoveries made in just the last month involves what astronomers refer to as heavy water, HDO, officially known as deuterated water. Basically here, instead of hydrogen atoms, it contains deuterium, the hydrogen that contains one neutron. And this is of course something that does exist on Earth, because in some cases hydrogen atoms may be replaced by their heavier cousins. And so in astronomy, the ratio of this heavy water to regular water can actually act as a kind of a cosmic thermometer. It allows us to indirectly measure temperatures. And that's because chemical reactions that create heavy water are extremely sensitive to temperature and only happen in very specific cold conditions. And that's essentially what this new study is about. A team led by Luis Salazar Manzano at the University of Michigan relied on the ALMA observatory to measure the ratio of deuterium to hydrogen inside the comet. In the process discovering something that they really didn't expect. 3I Atlas seems to contain approximately 30 times more deuterium, or technically more semi-heavy water, than any other comet we've seen before, including everything in the solar system, and 40 times higher than what we usually find in Earth's oceans. Okay, so what exactly does this mean? Well, this tells us a little bit more about the original star system where the comet came from. And specifically it tells us that it formed somewhere where it was extremely cold compared to the solar system, very likely below 30 Kelvin, or approximately minus 406 Fahrenheit, minus 240 Celsius. And so that's just a little bit warmer than the absolute zero, which implies that the cloud of gas that formed this comet and actually formed the entire star system where the comet was from, was probably extremely isolated and very likely much quieter and much more passive than the one that formed the Sun. In contrast, we know that the Sun seems to have formed in a somewhat crowded cluster of stars in a very typical star-forming nebula. And in these types of nebula, things are usually much warmer and the levels of deuterium are much lower. But the home of this comet was potentially lonely and seems to have formed in some kind of a very frigid corner of the galaxy. Now at this point we have no idea where this would be, But that's right now the only explanation for why it seems to contain a much higher level of deuterium. On top of this comet is also a bit alcoholic. Alright, not that kind of alcoholic. We're talking about methanol. Here observations from ALMA once again revealed that strangely enough this comet is bursting with methanol, a type of alcohol. And the amount of methanol relative to a lot of other molecules like hydrogen cyanide is much higher than anything we usually see in any other comet. In this case, the ratio of methanol to hydrogen cyanide was between 70 to 120, making this one of the most methanol-rich objects ever found. And on top of this, unlike typical comets, where molecules usually originate from the nucleus or from the core of the comet, here methanol appears to be coming from both the nucleus and from the icy dust grains. So essentially, it's literally filled with methanol compared to anything we've seen before. But before you try to make a funny joke about a drinking party on this comet, remember methanol is not drinking alcohol. It's the stuff that makes you go blind. So don't expect any parties there yet. But in terms of scientific discoveries, this discovery proves that the recipe for building planets and comets seems to vary significantly across the entire galaxy. And so the extreme methanol enrichment suggests that the comet formed in the environment very different both in terms of temperatures and chemical abundance compared to the solar system. Although importantly, because methanol is also an extremely important organic molecule necessary for life, finding this precursor to even more complex chemistry potentially implies amino acids can exist elsewhere and might even exist in much higher abundances around other star systems. So basically, good news for potential life somewhere out there. As a matter of fact, comets like this one may even serve as a kind of a delivery truck for a huge chunk of organic matter for some kind of a lucky terrestrial planet somewhere out there. And so for all we know, maybe this is actually how life could start somewhere else, through essentially a massive collision with such an object. And if you actually want to learn more about how impacts potentially create life, check out one of the recent videos about a very strange discovery in Korea that was just made a few days ago. The video should be in the description. But then, around the same time, the James Webb Space Telescope also discovered something else that's just as important: methane. And specifically, a trail of methane that was not seen in any of the previous images. And so, as the comet was arriving, it didn't show any methane because the surface was very likely completely fried by the cosmic rays during its billion-year journey. Or basically, it had this very hard crust on top of the comet that was preventing the insides from leaking out. But as it passed the sun, the heat broke that shell apart, cracking the surface and revealing the fresh icy interior, with the comet suddenly releasing a lot of stuff all at once in just the last 3 months, which confirms that the comet's core seems to be rich in a lot of these volatiles, once again providing evidence that it very likely was formed in very cold, shielded conditions. And in contrast, in most comets in the solar system, we usually see methane from really far away as the comet approaches the sun, because once again the solar system seems to have comets that are just different. In this case, most of the methane though actually started being emitted after the comet passed Jupiter on the way out, so basically in just the last month. But this once again also confirms that many of these interstellar comets potentially contain very similar crust on the surface that form as a result of billions of years of interaction with cosmic rays that bake the surface so much that it becomes kind of like this hard shell. The shell that can be meters in depth and that actually takes a while to break. So in some sense, you can think of these comets as these like chocolate-covered peanuts or something, with the chocolate forming as they travel across space. And yeah, I'm only giving you this analogy because I'm kind of hungry right now. Anyway, moving on. But methane in this case is once again great news for astrobiology. Just like methanol, it's a simple organic molecule that's usually a key ingredient for complex chemistry of life. So this comet seems to contain a lot of these prebiotic molecules that in theory could create life somewhere out there. But then we also have studies that try to once again estimate its overall age. And so by looking at the speed of the comet and the isotopes in its gas, scientists now estimate that this object has to be anywhere between 10 to 12 billion years old. Now we don't really know exactly how old, but it definitely seems to be at least twice as old as the solar system. And this implies that it formed when the Milky Way was still in its infancy, long before the solar system even existed, and the stars that were forming were very different too. So this is basically a kind of a interstellar fossil, a relic from the very early history of the galaxy. Then we had this. These are actually relatively new observations, in this case from a probe that's extremely close to Jupiter. This is the Jupiter Icy Moons Explorer. And this mission, referred to as JUICE, is currently on a very long journey to Jupiter that is going to reach in 2031. And though its main mission is to explore Jupiter's moons, Ganymede, Callisto and Europa, since it does have a camera and was actually extremely close to this comet, it allowed researchers to directly capture everything, even though the mission was not supposed to start doing any science yet. But because ESA realized this mission was in a perfect position, especially because we could not see the comet from Earth at this point, they tried to capture as much data as possible. And that's despite the fact that the spacecraft had to use its main antenna as the heat shield because it was just a little bit too close to the sun. And because of this, it was only able to transfer images very slowly, and so only 120 images were captured at the end. But even here we have images that show us a very active comet with two distinct tails, a plasma tail formed by charged particles and a dust tail made out of solid particles, despite the fact that this comet came from a different part of the galaxy. And that's usually exactly what we see from various comets in the solar system too. And so in terms of physical behavior, or at least in terms of how it forms tails and vents gas, it was very similar to comets we know. And that's actually also important because it implies that the process of cometary formation seems to be more or less the same across the galaxy. And that's despite the fact that some planets and some stars are much colder, and the chemistry could be different too. Okay, so having said all this, what have we learned so far? Well, first, we always had this assumption that the solar system was a kind of a typical example of how planets and comets form. But 3i Atlas is showing us that we might be the weird ones. Or basically, the solar system is definitely not your typical star system. And so the fact that this comet formed in such a different, colder environment suggests that many planetary systems across the Milky Way possibly have very different creation stories, with some astronomers like Darryl Seligman from Michigan State suggesting that either the solar system is just very unique and very special, or the current ideas about planetary formation are not complete and are missing some very crucial piece of a puzzle. But by studying these comets and these interstellar visitors, we're finally getting a much broader galactic perspective on how other star systems are born, and of course, how the solar system was created as well. Now, we don't really have any conclusive answers yet, but this is essentially where it all starts. And so just to summarize, in just the last few months of observations, we've already discovered that 3i Atlas seems to be extremely ancient, possibly as old as 12 billion years old. We also discovered that it seems to have formed in very cold environment that's much colder than the solar system, and also chemically distinct, containing massive amounts of heavy water and methanol. But it also behaves just like a normal comet, proving that the basic laws of astrophysics do apply everywhere. So definitely some exciting discoveries. But before I go, just one more quick reminder. Despite some of the early speculations, a lot of groups like SETI and other teams using FAST telescope in China have now thoroughly searched this comet for any signs of potential alien technology or alien signals. And absolutely nothing has been found so far, with the only radio signals being emitted essentially being formed by very natural means. Absolutely no aliens, nothing unusual about this comet, and it seems to contain only natural radio noise. And so yeah, once again, sorry, no aliens here. But as 3i Atlas drifts past Saturn and eventually exits our solar system for good, we may get some additional observations in the next few months as well. As a matter of fact, the data is still being collected, and astronomers are going to be sifting through this data for at least a few more years, which means that we might have some additional discoveries in the next few months. And until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.